So in this lecture, we are going to continue with this idea of optimization, okay, finding maximums and minimums of functions. And today we're going to look at I want to look at one specific function that has to do, definitely business driven, has to do with inventory control. And then we're going to look at another kind of more geometric example of how we can do optimization. So I hope that you've read the book, but I just want to highlight a couple of things at the very beginning here. So the first thing we're going to talk about is we're going to talk about problems involving inventory control, okay? So here's the idea with inventory. So I'm going to do a little bit of a lecture here. If you understood everything in the book with the inventory control, you can fast forward maybe to or skip to the next example. But here's the idea with inventory control. What we have, let's say we have a business, okay, and that we are ordering, so some things need to happen here. We want to be ordering supplies regularly. So the example we're going to do, I rarely do examples straight from the book, but I actually really like how they talk about this example. So our inventory control, the example we're going to use is maybe we are a grocery store or a convenience store, and we are going to be ordering orange juice. So orange juice, we would order regularly, right? Because we assume that people like orange juice pretty much regularly. So I'm going to be ordering supplies regularly. Now, here are some things that we're going to need to consider. If we order a large amount, let's talk about the cost associated with that. What that means then, if I order, like let's say I need, I'm going to just order 1,200 cases of orange juice all in one go, and I'm getting that 1,200 cases that's going to last for the entire year. Well, the problem with ordering a large amount is that we have high carrying costs then. So what we mean by that, if I order orange juice, if I order all the orange juice I need for the entire year, I need to find a place to store it, right? If this is like, I think in the example, it's frozen orange juice, maybe, yeah, frozen orange juice, then I need to find a freezer to put it in. I need to pay electricity to keep it cold. The ordering a large amount is going to incur high carrying costs. Whereas if we have frequent, so the other option then, let's go to the other kind of end of this. What if I decide, well, okay, fine, I don't want to deal with the high carrying costs, then I'm just going to order a bunch of orange juice. I'm going to order maybe whatever orange juice I need just every week, right? So that I only am filling in the things that I need like in the actual grocery store, and I don't have to worry about carrying costs. I don't have to worry about storing 1,200 cases of orange juice in a freezer. Well, the problem with that is now we might have high ordering costs. So what could be some of the costs associated with ordering orange juice? Well, shipping, maybe they have some sort, sometimes you have fees just for putting in the first order, like a processing fee. So shipping is going to be the big one. Maybe it takes time for the person who's in charge of doing that. I have to pay that person to do that ordering. And as opposed to doing like we had up here, one big order, now I'm paying that person to make lots of frequent small orders. So what we're going to look at is we're going to look at kind of the happy, I don't know if happy is the right word in mathematics, like happy middle ground, right? What I need to find is I need to figure out where, and this is the optimization here, I want to minimize my costs, right? What I want to do today, what we're going to talk about, is I want to minimize my carrying costs and my ordering costs. And what we're going to see is that our inventory cost, so this is what we call inventory cost, that is going to be equal to what I'm paying for my carrying costs. Basically, what I'm paying to hold whatever the product is, right? Carrying it from one month to another, plus my ordering costs. So what we're going to develop today is we are going to develop the carrying cost is the one that's a little bit tricky. The ordering cost isn't too bad. Usually they'll just tell us like it's cost $75 per order, and so that won't be too bad to do. But what I want to do first is I want to talk about an example of what is this carrying cost and how do we determine it, okay? So let's just go ahead and Don't know why it always does that with my. Let's go to a different layer here. And I'm just going to put this example down. This is example 1 in your book. So I am kind of copying your book here a little bit. I don't usually do that, but I think this is a pretty good example. So we have a store anticipates. I'm just going to put plans. That's shorter. Plans to sell 1,200 cases of orange juice. Let's just call it OJ from now. I'm a little lazy this morning. Sold at a steady rate during the year. Oh, I just messed up my. At a steady rate. So I want to stop right here and say something about that. So maybe you sell more orange juice in the summer. When we do stuff like this, what we're doing today, when we make up this equation, when we look at finding the minimum, this is what we call mathematical modeling. Mathematical modeling is a way for us to describe the real world using mathematics. So remember, I don't know if I've said this in my videos yet, the mathematics is pure and true and all that is right. The problem also, though, with mathematics is because it's so pure and true, right? We live in this, what I call perfect math world, where everything must be perfect, right? So we know that we can say it's a steady rate. We know we are not going to be selling, three things of orange juice every single day. It'll fluctuate a little bit. But what a mathematical model does for us is it helps us describe real life as best we can with mathematics. So what we're going to do is we're going to do the steady rate. If you were really doing this as a business owner, you might do this. You might see what you're ordering, how many orders you should make, and then you adjust that, right? You adjust it as things change. Okay, so a little bit more information. Whoa. So we know it costs, so this is given to us. It costs $8, okay, to carry one case. Of orange juice for 1 year. All right, so find the carrying costs. We're just going to focus on the carrying costs for right now because that's the hard part about figuring out these inventory costs. We'll see that the actual order costs aren't that bad. Find the carrying costs if, and we have a couple situations here. Let's say we order once a year. Okay, so I want to look at ordering once per year. I want to look at ordering twice a year. And I want to look at ordering 4 times per year. Again, remembering how much orange juice do I need? How much orange juice do I need for the entire year? I need 1,200 cases. So I want to just kind of show you what happens with this A and give you kind of a reasoning for how we're going to determine these carrying costs, because we're assuming we're going to actually be selling some of this orange juice, right? So I can't just take 1,200 times 8 because I'm not going to carry that 1,200 cases over the entire year. I'm going to be selling some of them. So if I'm going at a steady rate, you could say, well, Sarah, if I divide this by 12, I'm selling about 100 cases, right? Give or take every month. But that's even a little bit too complicated. So I don't want to get to something too complicated here. So what we do, so if we look at kind of a graph of this, oh, that was a pretty good straight line, and I didn't even use my shift key. Wow, go Sarah. All right, so this is going to be time on the x-axis. That usually is true. And this over here will be the number of cases. All right, so I'm going to take I'm going to start right here. Oh, I thought I had used the shift key here. Okay, and what's going to happen, I'm not going to reorder it all. I'm going to start with 1,200 cases, and then by the end of the year, if you notice, I have 0 cases because I'm going to spend all of that. So what we're going to do, we are going to compute our carrying costs. So we'll just put a little note here. Carrying costs. Carrying costs will be computed. on an average. So an average inventory. Your average inventory during, and we're going to call this during the ordering slash reordering period. So basically what that's saying is I want to do my carrying costs, right, to be calculated on my average inventory in between my orderings. So if you look at this here, I have 1,200 cases over however much time we have, right? And I want to know what is the average number of cases that I have over that entire time, okay? So look at what we have. We're going to go, if we say, basically I start off with 1,200. And I'm going to take an average, and basically what you're doing, this is going to look a little bit silly, but look at what I have, my carrying case, the number of cases I have. I start at 1,200, I end at 0. So what is the halfway, or what is the average between 1,200 and 0? I know that looks a little silly, but this is how we find averages, right? If I wanted to find the average exam score I have, I add up my exams and I divide by the number of exams. So my average in this case, the average number of cases that I'm carrying over this year is 600. And that kind of makes sense, right? That's half of them. So that is what that is how I'm going to calculate the carrying costs. Again, this is just an average. Remember, why do we do this? Why don't we take 8 times 1,200? It's because we're going to be selling those cases. Okay, so we're going to be selling those cases so I don't have to, by the end of the first month, if I'm at a steady rate, I only have 1,100 cases. I hope that makes sense. Or 11K. Yeah, 1,100 cases. Is that what I said? I don't know. Anyway, that's why we want to take this average. That's why we want the carrying cost to be computed on an average inventory, because the number of cases is going to be steadily decreasing until the end of the year, and so I'm not going to pay I'm not paying $8 for that full 1,200 cases for the entire year. So in this case, for part A, what would my answer be? My carrying costs then, because it's going to be based on, the average number of cases, I'm going to take $8 times 600 cases. Okay, and so my average carrying cost is going to be $4,800, right? And you can think of this, if we think of this as units, this is $8 per case, and this is times 600 cases. So if you notice, my units cancel and I just get $4,800. So it'll cost me $4,800 to order that 1,200 cases at the beginning of the year. Let's see what happens with twice a year. Let me really quick add a new layer. Let's go to that. Okay, so B, twice a year. Whoops. All right. Sorry about this. Let's go there. All right, so B, twice a year. So here's what happens. Okay, so if I want to order, I still need to start off, okay? I still need to get 1,200 cases. But if I think about twice per year, what is the number of cases that I'm going to have per order? So if I take 1,200 and I divide it by 2, that's going to be 600 cases per order, because I know I need a total of 1,200. Okay, so now I'm up here at 600. I will order those 600. I will get to 0, and then I'm going to put in another order. Okay, another 600. So look at here, I have 600 plus 600, and now this is the end of the year. Okay, so this is my first order, and then right here at this moment, this is going to be when I place my second order. And so again, let's talk about carrying costs. So again, my carrying costs, if I look at what is my average, right? What is my average inventory during my order reorder period, meaning during this first order period right here. And it'll be the same here as well. Well, that would be 600 divided by 2. It would be the average. It would be the midpoint of what I have. So I'm carrying at any given moment, I have on hand about 300 cases from here to here. You know, maybe this is after 6 months or whenever. And so what are my carrying costs then? My carrying costs then will be $8 or $8 per case times 300 cases. So if you notice, that's only $2,400. I've actually cut my carrying costs in half. Let's look at 4 times per year. So we have the same idea here, right? I need 1,200 cases total. Okay, but now instead of ordering 600 at each time, I'm only going to order 300. So I'm going to have to reorder. This is not going to be perfect, but in life, really, what is? You should look at your book. Give a nice little. Okay, so how many am I going to order each time? Well, if it's 4 times per year, I'm going to take 1,200, divide it by 4, and each order will have 300 cases. So I know I'm going to be at 300 cases up here, right? And here's my first order, here's my second order, second order, third order, and fourth order. And how many cases are in one of these? Let's just look between 2 and 3. 300 cases, right? So I want to find the average inventory during that time in between ordering the order reorder period. So I would take 300, divide it by 2, and that's 100 That's not dollars. That's 150 cases, people. So what are my carrying costs? I'm really getting lazy now. Let's call that CC. Again, that is $8 times 150 average cases. And so look at we're at 1,200. So if you see, we've cut this in half. So you could say, but Sarah, why don't we just keep doing that then? What if we ordered 6 times per year? What if we ordered 17 times per year? Well, again, now we have to consider the ordering costs. So let's do an example with the ordering costs. So let me clear this out. The other thing I really want to quickly talk about is let's do a definition really quick, and then I want to do 2 examples. And this is going to be a long lecture, but you know what? More for your money. You pay good money to take this course. So the definition is something that we call the economic order quantity. Or if you want to sound cool, tell your business calculus friends the EOQ, because that is how you sound cool, people. And what this is, the economic order quantity, okay? What that is this is the quantity that you would order each time, right? At each order, the quantity ordered each order. That minimizes, so there's my optimization, minimizes inventory costs. Remembering that inventory costs equals carrying costs plus ordering cost. Okay? That is clear, right? IC equals CC plus OC. All right, let's do an example. So let's consider, consider the same example. So let's consider the orange juice example from before. We don't need to reinvent the wheel here. So I know I want 1,200 cases sold at a steady rate during the year. Okay, and so what I want us to find is I want us to, well, a couple things here. I need to tell you something else. Let's assume that it costs, or let's just assume that ordering costs are $75 per order. So that might be the initial processing fee, that might be shipping. Okay, so $75 per order. Again, this is not perfect because I can already hear you saying, Sarah, but if I order more, the shipping cost will be more. This is again a mathematical model. This is going to get us in the ballpark of where we should be. Assume the ordering costs are $75 per order. So let's find, and it's the same $8, okay, for carrying. So let's find the EOQ, the economic order quantity. So again, I want to find what minimizes this. So I want us to define some variables here. So I'm going to let X equal the order quantity. I would recommend using these variables each time. Okay, so, and I would recommend defining them each time. Even though we know now that X is going to be order quantity, why not write that down every single time you do an inventory cost problem? What I would do is go ahead and write this down each time. I'm going to let, so what are our unknowns? X is the order quantity. That's the number of cases in each order. The other unknown for us, we are going to call R, and that is the number of orders that we're going to do. Okay? So these are my unknowns, right? So I want to know, first of all, how many times should I order per year and how many should be in that order to minimize our inventory costs. So I also want to point out here that X divided by 2, okay, this is the order quantity. So X divided by 2 is going to be the average inventory in the reordering period, right? That makes sense, right? If I want to order 300 cases each time, okay, then 300 divided by 2 is my average inventory during that. Oh, that is horrible. Reorder, sorry about that, period. All right, so let's talk about the actual math for this. All right, so here I need something that, so what do I want? Whoa. I want more ink flow. That is what I want. You would think after all these videos I'd be really, really good at this. Okay, so what do I want? I want the minimum inventory cost. So I want the minimum inventory cost. Let's just call that, let's just call that C for cost. I don't know. Let's get crazy. So here is C. These are the costs I'm going to have. Now remember, it's going to cost $75 per order. $75 times R. So if I have 10 orders, it'll be $750. Also, so there's my ordering cost, right? Ordering cost. Now I need my carrying cost. So what is my carrying cost? It's $8 times the average inventory over a year. Okay, this is my carrying cost. So that's what we developed in that last example. So I have, what is my equation here then? It is 75R plus 4X. Okay, that is the cost of doing R orders per year and ordering X amounts of cases in each order. So look at, this is what we did on the last section. Our wants, well, our wants with regard to business calculus problems, right? Our wants as a person is probably a little bit different. And then here's our constraint. Now this one's a little bit tricky, but this one's going to be the same every single time. And I'm just going to write this down and then we're going to talk about it. The constraint is that X times R must equal 1200. That 1200 had to come in somehow. And let's think about this. This is the number of times you order, so number of orders per year. And this right here is the number of cases, right? So think about that. If I ordered 3 times a year, then I would do 400 cases each time. So 400 times 3 is 1200. If I want to order 6 times per year, then I would adjust. This is why it's a constraint. X and R have to be adjusted to make sure we get 1200. So I need 1200 cases total. Good, and now we're just going to do what we've always done. I'm going to go ahead and solve for R. I would get 1200 X to the -1. Now I'm going to take this C here and I'm ready to plug that in, and I am ready. This is going to be a good time. I am ready to find the minimum of this. Okay, so let's simplify that a little bit. Oh, I am not prepared. I need a calculator. Hold on, people. Problem is in my notes, I didn't actually do this. Let me just grab a calculator really quick. So I'm going to do 75 because I don't feel like doing 75 times 1,200 in my head. Oh, 90,000. Good. So what do we have? We have that C is 90,000. X to the negative 1 plus 4x. And take the derivative because I want to find where does this function have a minimum value. Negative 90,000 x to the negative 2 plus 4. Okay, we need to set this equal to 0, people, so I'm going to rewrite this. That negative exponent puts that sucker on the bottom. This is plus, now the 4, I'm going to multiply top and bottom by x squared. Okay, so that I can see I have a negative 90,000 plus 4x squared all over x squared. And when is this guy, and then I'm going to set it equal to 0. Well, when is a fraction equal to 0? It's when the numerator is equal to 0. Ooh, now we're going to start working up here. So I have a negative 90,000 plus 4x squared equals 0. That tells me 4x squared equals 90,000. So I'm going to take 90,000, I'm going to divide it by 4. I'm going to take 90,000 and divide it by 4. Oh, that's lovely. I get then that x squared, this is going to be great, equals 22500. I bet that's a perfect square. Let's see. Yeah, nice. And normally I would bring in a plus or a minus, right, when I square root, but we can't have negative cases of orange juice. That'd be like the customer coming in and giving us cases of orange juice. Silly. So look at what I have. What is X? 150. That's 150 cases. We saw 150 before, right? When we looked at reordering. Well, that was our average inventory. Never mind. So this is what we call the EOQ. So what I want you to do is finally a sentence. So you would just say 150 cases per order is the EOQ. And if you want to there, you could even say, and we'll minimize inventory costs. I hope that makes sense. There's another example in your book, so you should look. We just basically did example 2 in your book. I would like you to also look at example 3. It says everything is the same except we want 48. So look at example 3 in your book. Okay, and that is on page 174. So the only difference in example 3 is that instead of 1,200 cases, we want 4,800 cases. So the only thing that's going to change is it's going to change this number right here. Okay? All right, I want to do one more example and then we will be done. One more example of the type of problems that are going to be in here. Okay, so this one is not an inventory cost one. So a corral, this is like for you ranchers out there, right? We need a corral and we need it to be 54 square meters. Okay, that's the area of it. And this corral is to be fenced off. All right, and then divided. Okay, divided by a fence, by another fence, into 2 sections. And I'm just probably going to set this up for you because we're almost at a half hour, and I'm a little worried I've lost you. All right, so the question here is, again, this is an optimization problem. Find the dimensions. Okay, find the dimensions. So the amount of fencing is minimized. Why do we want to minimize the amount of fencing? Because I don't want to pay for it. It's all about money, right? All right, so the amount of fencing is minimized. Okay, so this is a totally different example. 2.6 is kind of a hodgepodge of different examples. 2.6, I want you to realize we are not going to do examples such as example 4 and example, well, just example 4 really. You can look at example 5. We also are going to, this is really the way that we're going to focus on kind of these fencing problems and stuff. There's one on your homework that's kind of like the one I'm doing right here. It's a little bit different, so you want to look at the fun sheet because the fun sheet's going to have one similar to the one on your homework. So what I need to do first is I need to draw a picture. All right, so I have this corral, and I guess I should have said it's a rectangular corral, and for those of you ranchers out there, I would assume most of your corrals are rectangular. I don't know, I guess you could have. All right, why isn't that working? There we go. All right, so there's my corral, and the big thing that makes this an interesting problem is that I want to divide this guy into two separate corrals, basically, another fence into two sections. So what I want to do, I drew a picture, and now what I want to do is I want to label. So what I'm going to do is I'm going to label this whole side X. That's the amount, like the meters, it's in meters, of fencing I need along this side. And then I'm going to let this be, I don't know, let's get crazy, and let's call this Y. That's the amount of fencing I need for this. So what do we want? We want the minimum amount of fencing. Minimum fencing. So I want minimum, oh, I don't even want to do that. I just want minimum of, so I want the minimum of, sorry about that, of, I don't know what we'll call this. Let's call it F for fencing. How much fencing do I have? Well, I have, right, for X, I have fencing here and here, okay? So for X, I'm going to have two of them. 2 times X, that's the amount of fencing I have in the X direction, okay? And then for Y, I have fencing here, here, and here. So how many of those? We have 3Y. Does that make sense? So that's the amount of fencing I have where X and Y are the meters of fencing. And what is our constraint here? Our constraint is I know the area. I know that the area of this whole thing right here must be 54. So my constraint is that X times Y equals 54. And then I'm going to let you finish this one. I would probably solve for Y here, and I would get 54. Well, maybe I won't. Maybe I'll just do it. X to the negative 1. Plug that back into F. So I would have 2X plus 3 times 54X to the negative 1. I'm going to go ahead and take the derivative. So this is 2. Now I'm going to have minus because this negative is going to come down. And I think that's 162. And then I would have x to the negative 2. And again, the trick with these is to take that negative exponent, rewrite this guy on the bottom, do x squared, and then get a common denominator. So I would have 2x squared minus 162. There are other ways to do this, but I think that makes the most sense. So again, I just took that 2 and I multiplied by x squared over x squared. So I get 2x squared minus 162 over x squared. Set that sucker equal to 0. When is a fraction equal to 0? It's when the numerator is equal to 0. And it looks like we get x, once you solve that, to be 9. That is 9 meters. You also need to find y. What you'll see is y should be 6 meters. Oh, and, oh my goodness. Oh, goodness gracious, Sarah. This 9 right here, you need to show me it's a minimum. Oh, we need to do that on the last one. So a minimum, if I put 0 into the derivative here, I only need to put it in the numerator. I would get a negative. If I put 10 into this numerator here, I get a positive. So sure enough, we have a minimum. I need to see this. I need to see this check. Okay, and then you would state your answer in a sentence. So let's go back to this one really quick. Well, let's see. Oh, I lost it. I cleared it. So anyway, on that last one, when we found, oops, gotcha. Sorry about that. It gets very mad at me when I do that. On that last one, darn it. Wow, that's a little freaky. But on this one, when we found, right, we found that 15 was our EOQ. We need to make sure, whoops. we need to make sure we have x equals 15. We need to make sure that that gives them in. So you're going to put 15 right here, and you're going to check and make sure that it goes from a negative to positive. And I want to see that check. You know what? If you are still with me after 35 minutes, I applaud you. I'm happy you're here, even though I don't actually know that you're here. I just am pretending you guys are all watching these and enjoying them. As always, please, please, please contact me if you have any questions, and have fun.